Today's lesson, I want us to check the concept of quadratic function, mostly known as the parabola. So this can be given in three different ways. And then the general equation for a quadratic function, we know that it's given by y is equals to ax squared plus bx plus c. Then the second one can be given to you as a into x minus p all squared plus q. Then y can be given by a into x minus x1 x minus x2. So these are the possible ways in which they can bring this quadratic function to you. Then if you can observe all these equations, they have a in them. So a is common in all these equations. So let's talk about the effect of a in all these equations. A determines the shape of the graph. So if a is greater than 0, it means that we are going to have this shape of a graph. It means we are going to have a smiley parabol. But if a is less than 0, we are going to have a sad parabol. So meaning that when we say a is greater than 0, the value of a should be positive. And if the value of a is positive, then we're going to have a smiley parabol. Then when we say a is less than 0, then we mean that the value of a in that case will be any negative number. Then we're going to have a sad parabol. All right. Now I want us to analyze equation by equation and the symbols involved in them so that we get to understand the effect of every symbol in each equation. So we take the first equation, which says ax squared plus bx plus c. So we talked about the effect of a, which determines the shape of the graph. Then when we talk about the effect of b, we have to understand that if given a parabola like this, a parabola is symmetrical about its turning point. So when we talk of symmetrical, we know that we have to divide the graph into two equal halves. So the only way to divide a parabola into two equal halves is about its turning point. Where the graph changes direction, then that is where the graph is divided into two equal halves. So this line that divides the graph into two equal halves is called the axis of symmetry. This is the axis of symmetry. So to calculate the value of the axis of symmetry, okay, so this line, it's a vertical line and it cuts the Cartesian plane on the x-axis. So it means that the axis of symmetry, we talk of the x coordinate. So to calculate the x coordinate of the axis of symmetry, we say x is equals to negative b over 2a. So this is how we calculate the axis of symmetry, the line or the vertical line that divides the parabola into two equal halves. So to calculate the x coordinate of it, which is the x coordinate of the turning point, we say x is equals to negative b over 2a. All right? Then to calculate the turning point of this graph, because now we have the x coordinate that divides the graph into two equal halves. So we know the value that divides the graph into two equal halves, which is the axis of symmetry. Then to get the y value, we're going to check the point of contact between the graph and the axis of symmetry. So if we know the value of the axis of symmetry, to obtain the y value of it, it means we have to substitute the value of the axis of symmetry into the original function of the graph, because the x turning point of this function is the axis of symmetry. So the turning point, the x coordinate of it is negative b over 2a. Then to obtain the y value, we say we substitute the x value into the original function of the graph. So if that explanation is too much for you, you will see that when we do the application part. So this is the effect of B. This is the first effect of B. B helps us to get the x turning point of the parabola, or the axis of symmetry. Then the other effect, we'll talk about it later. Then now let's talk about the effect of C in this function, or in this equation. So C has two effects again, but for now let's focus on only one. Okay, so C in this case is the y-intercept, because when we do the y-intercept, we let the x value be equals to 0. So as you can see, your expression here, it says ax² plus bx. So when you let x be equals to 0, it means this one and this one will go away, and then we will remain with C. So it means C in this case is our y-intercept. So this is the effect of C on this equation. Then you can be given an equation in this form, and then you will be required to sketch a graph, and then you have to follow a certain procedure in order to do that. Okay, so I think now we can check on an example so that we can learn how to sketch a graph. Here's our example. We're given f of x is equals to x² minus 5x minus 6, and then you are required to sketch a graph. So when sketching a graph, you need to do the following. The first thing that you have to do is to determine the y-intercept. And when we do the y-intercept, we know that we're going to let our x be equals to 0. Then the second thing is to determine the x-intercept of this graph by letting our y value be equals to 0. Okay, then the third thing is to calculate or to determine the axis of symmetry of this parabola. Then when you have the axis of symmetry, then you can calculate the turning point of this graph. Then now number 5 is just to plot all your points. You plot all your points and then join them with your hand. Then now we can try to sketch this graph by following this procedure. So it means the first thing that we have to do is to find the y-intercept by letting our x values to be equals to 0. Remember, we said the C value plays a role in this case to be the y-intercept. So without any calculations, we can see that our y-intercept will be negative 6. So when we're doing calculation, we said when we do y-intercept, we let the x value to be 0. Then it means y must be equals to 0 squared minus 5 into 0 minus 6. Then we see that our y value becomes negative 6. Because now we are dealing with a Cartesian plane, or a function is drawn on a Cartesian plane, we have to put this in coordinates form. Then in coordinates form, we know that coordinates are in the form x is to y, and then now our x value in this case is 0, and then our y value is minus 6. And then we can do number 2, we can find our x-intercept by letting our y value to be 0. So it means 0 is equals to x squared minus 5x minus 6. Then now we need to do a little bit of factorization and then solve for x. Then this is 0 is equals to, then when we solve this, it means we're going to have x minus 6 into x plus 1. Then it means x minus 6 is equals to 0, or x plus 1 is equals to 0. Then our x value now is 6, or our other x value is equals to negative 1. So this is our x-intercept. Then in coordinate form, it means we're going to have 6 is to 0, and then this side is negative 1 is to 0. Then now we have our y and our x-intercept. So to find number 3, which is our axis of symmetry, we know that the equation for axis of symmetry is x is equals to negative b over 2a. Then now we go to our equation. Our equation is like this. So the coefficient of x squared is the value of a, and then the coefficient of x is the value of b, and then this last value here is the value of c. So here it means the value of b is negative 5. We substitute here, it's going to be negative into negative 5. Then the value of a is the coefficient of x squared there, then it means it's 1. So we're going to have 2 into 1. Then when you simplify this, you're going to have positive 5 over 2. So this is the point when x is 5 over 2, that is where the graph will be divided into 2 equal halves. So when we have that point, the point of symmetry, or the axis of symmetry, then we can get the turning point. So to get the turning point, we said we are going to substitute this axis of symmetry, or this x value of the axis of symmetry, into the original function of the graph. Okay, so our graph, we know that it's given by f of x is equals to x squared minus 5x minus 6. So to get the turning point, we're looking for the turning points here. So we're going to say f of, where we see x, we're going to substitute 5 over 2. Then this is equals to 5 over 2 all squared minus 5 into 5 over 2 minus 6. Then when you get your calculator, then you punch the whole of this expression on your calculator, you are going to get negative 25 over 2. Okay, which is equals to negative 12 comma 5 in decimal form. So the turning point should be in coordinates form. So the x value for the turning point, we know that this is the value of the axis of symmetry, which is 5 over 2 is to the corresponding y value, it's negative 12 over negative 12 comma 5, or you can write negative 25 over 2. So when you have all this information, then now you can draw your Cartesian plane and start sketching your graph. All right, so now let's try to sketch this graph here. Then we need to draw our Cartesian plane. Then this is our x-axis, then this is our y-axis. So the first point that we calculated here was our y-intercept, whereby the point is 0 and negative 6. So 0 and negative 6 is somewhere around here. This is the point. 0 is to negative 6. And then we also find our x-intercept to be 6 is to 0 and -1. Then a point -1 can be here, then point of 6 here. So this is -1 is to 0, then this is 6 is to 0, and then we found our axis of symmetry to be 5/2, which is 2,5 in decimal form. So 2,5 is a point somewhere around here, and then our turning point was 2,5 and -12,5, and then it can be a point around here. So this is your turning point here, which is 5/2 is to -12,5. Then now we can try to join this with a freehand sketch. And there we have it. There is our function. So it's not drawn about according to scale, but if you can draw it according to scale, we're going to have a nice parabola of this shape. So this is how you can draw or you can sketch a parabola using the procedure that we've been doing there. So after drawing a graph, you might be required to do the following. You might be required to write down the domain and the range of the graph. The domain and the range of this parabola. So the domain of every parabola can be written in this form. X is the element of real numbers. Remember, the domain are all possible x values where the graph exists. So the graph is not restricted on the x-axis. So it exists from, or you can choose to write it as, the graph exists on the x-axis from x is the element of -infinity to +infinity. Either way, it's correct. But when we get to the range of the graph, we're going to focus on the y turning point of our graph. That is our main focus when we talk of the range. When we talk of the range, we focus on the y turning point coordinate. Okay, so we can write the range of this graph in this way. We can say y. Okay, so if you can check this graph, this point here, the y turning point of this graph is the minimum point where the graph exists. So from here going upwards, the graph exists. So it means any value less than this one, less than 12,5, the graph does not exist. But a value from 12,5 going upwards, the graph exists. So it means we want where the graph exists, every y possible value that the graph exists. So we're going to say y must be greater or equal to -12,5. All right, or you can choose to write it this way. You can say y is the element of, okay, y is the element of, if you want to write it in coordinate form. So this graph exists from -12.5 going to +infinity. So we can say this square bracket means we include the value here, which is -12,5, then it goes to infinity, then we put a curly bracket there. This is how you can write the domain and the range of this function. But suppose we're given this type of parabola whereby it's a set parabola, and then our turning point here is 1 is to 8. So the range of this graph, because the domain will not change for every parabola, the range of this graph, okay, if you can check the maximum point, when we talk of the range, we're going to focus on the y turning point. Always when we talk of the range, we check the y turning point. All right, so the y turning point in this case is 8. So if we want to write the range, so it means this graph is possible from 8 going down, going to negative infinity. So you can say this is the y value. Okay, so it means anything above 8, the graph does not exist. But if y is less or equals to 8, that is where the graph exists. So you can choose to write the range this way, or if you want to write it in coordinate form, you can say y is the element of, okay, then we include what? We include 8. We include 8. That is the maximum. But where does this graph start? It starts from negative infinity to positive 8, and this positive 8 we include it. So that's how you can write your domain and your range. All right, so now earlier we said that the c and the b on this formula, f of x is equals to ax² plus bx plus c. We talked about the b effect, the first b effect, which was to help us to get the axis of symmetry. Then the other effect of b is that it's responsible for horizontal shift. So b is responsible for horizontal shift. When you talk of horizontal shift, we mean moving to the left or right. So b is responsible for that movement. Then when b is positive, the parabola will shift to the left. So when b is positive, the parabola will shift to the left. But when b is negative, then it will shift to the right. The parabola will shift to the right. Then when we talk of the shifting, we can use the very same formula that we used to draw the graph, which was saying f of x is equals to x² minus 5x minus 6. And then a question might come and say shift the graph 6 units to the left. Okay, when they say shift the graph 6 units to the left, we know that when it shifts to the left, it's positive. So we're going to replace x. We're going to replace x with x plus 6. Then in this way, we are shifting the graph 6 units to the left. Then it means wherever we see x on this original function, we're going to put x plus 6. Then it means sometimes it can be written this way on your exam paper. Then this means they are telling you to find or to shift the graph 6 units to the left. So this will be equal to, then when we see x here, it's x, it means we're going to square this, x plus 6, then minus 5 into x plus 6, then minus 6. Then we solve this. So this is the new equation when we shift this graph 6 units to the left. So we can say y now it's equals to, when we expand this, we're going to have x² plus 12x plus 36 minus 5x plus 30 minus 6. Then now we're having y is equals to x squared, and then we add the like terms, then we're going to have plus 7x, and then we have 36 plus 30. Oh, here it should be negative. Negative by positive, it's negative. I'm sorry. Then we are going to remain with positive 6, and then we take this 6, then it gives you 0. So now our new equation, when we shift the graph 6 units to the left, our new equation becomes like this. So we've shifted the graph 6 units to the left. So when you go to the left, you add. Then if they say to you shift the very same graph, the original graph, shift f of x to the 6 units to the right, it means it will be like this. When you shift it to the right, then it becomes like this. We replace x with x minus 6. This is when we shift to the right. Then when you shift this to the right, our original formula was f of x is equals to x squared minus 5x plus or minus 6. Okay, so when we shift this to the right, it means we're going to subtract 6 from x. Where we see x, we put this, then this is 5 into x minus 6 minus 6. Then this is x squared. When we expand, minus 12x, then plus 36 minus 5x plus 30, and then minus 6. And then when we solve this, we get x squared minus 17x plus 60. So now you can see that this has shifted 6 units to the right. So this is the effect of B. Again, it's responsible for horizontal shifting. So horizontal shifting has a big effect on the equation. It changes to a certain degree. It's not the same as shifting vertically. So this is the effect of B when it works as a horizontal shift. I hope that one makes sense. And then when we go to C, again, C was working as our y-intercept. Also, C works as a vertical. It's a vertical shift. When we speak of vertical shift, we talk of up or down. All right. So this is responsible for vertical shifting. So if you want to shift this function x squared minus 5x minus 6, if you want to shift this function 3 units, maybe you want to shift this function 3 units up and also 3 units down. So when you want to shift this up 3 units up, you're going to say y is equals to x squared minus 5x minus 6. Then when you shift this up, it means you're going to add this 3 here. Then now your new equation becomes x squared minus 5x, then minus 3. Then now in this way, you have shifted the graph 3 units up. But when you shift it down, it means you're going to say y is equals to x squared minus 5x minus 6. Then you shift it 3 units down, you subtract 3 from the C value, then you're going to get your new equation as x squared minus 5x, then minus 9. Then this is how the vertical shifting works. So you can see how it's different from the horizontal shifting. So this is basically the effect of A, B, and C from that equation of the parabola. Right? So I hope it makes sense, and we can move to the second one. We can move to the second way in which they can give you a parabola in.